Uh-huh. So,
Yes, sir.
so we get water from the combination of acid and base, and basically we know that definitely there are ions. That ion formations will have to come together before it can be able to form water. So water is made up of ions, and that product of ions is what today we are going to talk about, the ionic product of water. And already we know that I told you the other time that water is a weak electrolyte. When we say weak electrolyte, it's not too much a good conductor. And when we say it's a weak electrolyte, that means uh, it's not too much a good conductor. Let me put it that way. We studied that last week, and it undergoes self-ionization to a small extent. That means it ionizes on its own to a smaller extent or to some extent. When we say self-ionization, I'm just talking about self dissolving. Let me put it that way, or self dissociation. Let me put it that way. If my English is right. So we are saying water it's not a very good conductor of electricity. In other words, it's a weak electrolyte. Good electrolytes are good conductors of electricity, and so that is it. And you know that the product of concentration, uh, before we can be able to get water, we are supposed to get a certain H plus ions and a certain OH plus ion, OH minus ions. And the H plus ions, we know we get that from the acid side, and we get the OH from the the base side. So when it comes together, when these ions comes together, we are able to get, or we are able to form water, which is H2O. I hope I've made myself clear.
Yes, sir.
Yes, sir.
Before you can be able to find this, we are supposed to get the product of the concentration of the H plus and that of the concentration of OH ions in water at a particular temperature. So that product of the H plus concentration and that product of the OH minus concentration at a particular temperature is what is known as the ionic product of water. Are we there? Is what is termed as the ionic product of water. Is what is termed as the ionic product of water. So, for instance, we say water partially dissociates. So let me just take you a little bit to equilibrium. Equilibrium, when you have a certain A, when you have a certain A plus a certain B and equilibrium, the sign is
Vessel.
what do you call it?
Vessel.
No. So it's equal to, let me just use the equal to sign, but you know that it's the reversible sign. One goes and one comes. So I have this. That will give us maybe C plus D. C plus D. Now to find for the equilibrium constant, which is given by Kc, or the concentration constant, then it will be the product of the concentration of C and D. So the concentration, then this is given by the when we do something like this. So this will be C. I don't want us to, if there are two and this, I don't want us to, let's just do it simply like this. The product of this all over the product of, what do you call it? So it will be the product of the products. There's a product all over the product of the reactant. When I say the product of the reactant, I'm talking about the multiplying the two, the concentration of the reactant. So the product of concentration of reactant. So this one will be A and B. So that is it. Immediately enter you. Immediately enter, you mute yourself. Oh, so that is it. So and a normal scenario, when we have a reaction like this will be the equilibrium constant. Now, when you get to equilibrium, we may talk about that. But I'm just using it. So when we have something like this, then for instance, here we are talking about water, the ionic product of water. So we are going to break the water into its ions. So for instance, if we have water which is H2O, and the other day I told you that water can either act as an acid or as a base. So for instance, if I bring two water together, one acting as an acid and one acting as a base, I should be able to get H plus I should be able to get H free O plus as a certain O H. So basically, this is what. So if you are to find the equilibrium of this, then definitely we know that the equilibrium of this will be equal to. Likewise, or in simply, we can also say that okay, let's just take this one. When I have water and I want to, when they dissociate, they are going to dissociate into their various ions that formed it, and they are going to get a certain H plus a certain OH, certain OH minus. So we are going to get something like this. Now, per studies or per equilibrium, or looking at this equilibrium formula, then that means the equilibrium constant of this Kc will be given by the concentration of this product all over water. So we are going to get the concentration of this H plus all over H2O. This will give us our equilibrium constant, or use applying the equilibrium law. That's what we are going to get. Now, let's looking at this same formula. Let's see if we can get an ionic product of water. Now, the ionic product of water just simply means that if water is this, when we break water into two, we are going to get this and this, so that the product of this and this should be able to give us water. That's what it simply means. And so now, this is just to so now looking at this, we can use this to find for the ionic product. And so if we cross multiply, then we are going to get something like Kc. I'm going to get a certain Kc H2O should be equal to the product of the concentration of the ions, or that is it. So let's say I'm saying that when water self-dissociates, it forms into H plus and OH minus. And this is normally gotten from the base aspect that made the water possible, or contributed to the formation of the water. And this is normally gotten from the acid component that contributed to the formation of water. And so now, right from our definition, we will just understand, or we will just have to know that the whole of this is equal to Kc, a Kw. So the Kw, which is the ionic product of water. So ionic product of water is given by Kw. Is equal to the product of, so ionic product. So that means the ionic product of water. So H plus So that is it. So finding the ionic product of water, this is the formula we are going to use. Forming the ionic product of water, this is the formula we are going the formula we are going to use. But it has a fixed constant at a certain temperature. Because when I was starting, I said that the product of the ionic product of water is normally the product of concentration of H plus and OH minus ions in water at a particular temperature. At a particular temperature, and that temperature we are talking about is 25 degrees Celsius. So at 25 degrees Celsius of water, that's what we get. So 25 degrees Celsius. When we are to convert it to Kelvin, we are going to get, who can tell me the conversion into Kelvin? It's going to be 298, right? 298 K. So at 298 K, the ionic product of this thing, ionic product of water is given by this, the concentration of this times this. That is it. So, and the constant, it's constant. It has a constant value. It has a constant value, like the way we have a radius of a circle and so on and so forth. It has a constant value, and the constant value is this is the constant. So the value is given by 1 times minus 14. So that is it. So the ionic product of water, the ionic product of water, the constant for ionic product of water is given by this. It's given by this. Oh, anyway, so that means Kw is equal to 1 by 10 minus 14 mole. You are talking about concentration. So mole square dot dm minus 6. So let's write it down. So this is the constant for ionic product of water. This is a constant for ionic product of water. Kw is equal to 1 times 10 minus 14 mole square dm minus 6. Dm raised to the power minus 6. And I've already explained that when we see the ionic product of water, we are just simply meaning that the product of the concentration of the ions of water. And we know that before we can be able to get water, there's supposed to be a certain combination of two ions, one from the acid side and one from the base side. The one from the acid side is normally the H plus, which we found here, and one from the base side, which is the OH. So the product of these two concentrations will give us the ionic product of the water. So ionic product of the water, that means the product of the ions of the water. That's simply what it means. So I hope I've made myself clear. Hello.
Yes, sir.
I hope I've made myself clear.
Yes, sir.
And we are seeing that it should be at a standard temperature of 25 degrees Celsius, or at 25 degrees Celsius, which is the standard temperature. The value for your Kw is given by 1 times 10 to the power minus 14. So at 25 degrees Celsius, or in Kelvin is 298 Kelvin. The value for your ionic product of water is given by 1 times 10 to the power minus 14. 1 times 10 to the power minus 14. 1 times 10 to the power minus 14. Now, let's see if we can be able to this thing. We can be able to so this means that, let me clean it. So that is it. So looking at this, we can comfortably say or confidently say that and they are equimolar. When we are saying they are equimolar, that means they are equal. Now equal because you know water is as a result of what do you call it? The pH of water is neutral or neutralization reaction. Water is neutral. Let me put it that way. So before one can be neutral, then that means equal, the same amount of ions of protons. Let me put it that ions of the protons. So in other words, the H plus should be equal to that of the OH minus. When it comes together, we're able to get water to be neutral. I hope you are getting it. Are we getting it? So that means before we can be able to say that, so equal amount of this concentration should react or should come together should come together or should be joined to this before we are going to get a neutral water. And so this will mean that, and if you're looking at this, looking at their mole, you realize that this is 1:1, right? It's to also 1, looking at their molarity. So in other words, you see they are equimolar. That means they have the same molarities. And so in that case, we can, looking at this, we can confidently say that this H plus, concentration of H plus, when this ends, you start again for the last time. So the concentration of H plus should be equal to that of what? H minus. Do you get it here? So let's equate all to let's equate all to maybe X. But we know that the product of these two should give you that of water, or should give you the ionic product of water. And so if this and this are equal, so if this is X, this and this is equal to X, then that means when we factor X here, we are going to get X squared. And so we are going to get KW is equal to X squared, because they are identical, or this and this, they are the same. The concentrations are the same. And so we are going to get S squared. Now when we get S squared, but we know that KW, we are given KW to be 1 times 10 minus 14 mole, minus 14 mole 2 dm minus 6. So it should be equal to S squared. Now I want to we want to prove that they should be equal, or they should be the same. So 2. So before we can get X will be the root of this, right? X will be the root of this. So X here will give us 1
Yes.
point. 1 times 10 to the power minus 7. Minus 7 mole squared dm minus, yes.
Please, would the mole be squared?
Mole liter, sorry. It will be minus 1, sorry. We take away the distance, so it will be minus 1. I hope you get it.
Say minus.
It will be minus 1. Oh, sorry, mole.
Okay.
Let me give you the units correctly so that you know. So you can. So if you square the whole of this thing, you get to understand. So this is squared, then so it will be 1, not minus. Sorry. So this one will change to minus 3. Oh, I'm lying.
Yeah.
Which is equivalent to liters raised to the power minus 1. So we can get this liters raised to the power 1, or in other words, dm minus 3. Either I don't have a calculator, so you can use your calculator to do this. So this is what we are going to get. So this means that one of this is 1 point is equivalent to the concentration of OH is equivalent to 1 times 10 to the power minus 7 mole liter minus or something, or per liter. Let me put it that way, per liter, or per dm cube, per dm cube, per dm cube. So they have. So now we can confidently ascertain that they are equimolar, or they are the same. They have the same concentration. I hope you get it.
Yes.
So at 25 degrees Celsius, we are going to get that. So this means that if and another if you are doing the calculations and this is greater than this, the value you are getting, the concentration of this is greater than this, then it means that the solution is what? It means that the solution is. Maureen, tell me.
So when what is greater than what?
When the H plus ions is greater, or the concentration of the H plus ions is greater than that of OH minus, then it means the solution will be
Acidic.
acidic. When it is lesser, then it will be what?
Basic.
Basic.
Or basic.
Or alkaline. When it's equal, then that means it's water, right? Or it is neutral.
Yes, sir.
That's what it means. So now let's advance the class, and I hope you've all, those who are copying are done copying. Law and order to the wonderful people of Dumba. The deputy commander of Persons finally admitted stress on the importance of security within the communication area. The fundamental needs of nation.
Can't hear you.
Yeah, I'm coming. Don't worry, I'm not talking. And territorial integrity. It is when these are guaranteed that the citizens can go about.
Maureen, please, when you're done, forward the notes to me, okay? My lens are not with me right now, and I can't see what is writing. Okay, I beg. Okay.
My handwriting is not nice. That's what you're trying to say.
Sir, sir, no, my lens are not here. That's why.
You have 4 eyes. Oh, sorry. I don't know. I'm happy, but I'm just happy. Hey, 4 eyes.
That's not fair.
There's nothing in this world which is fair. Nothing seems to be fair. The only fair people are the Voltarians. Even now, when we have dark people among them. Nothing in this life is fair. Oh, baby girl. Well, even white, it makes you look so sweet and sexy.
Say, say that it's okay. Say, let's continue.
It is a man. It is a man. So let's continue. So we are going to look at the pH, finding the pH or pOH of an aqueous solution. Find the pH or pOH of an aqueous solution. Now, simply when we say pH, we are talking about the acidic content or the acidity. When we say the pOH, you know the H means acid. You get it? And the pOH is the what? The oxide or hydroxide. So definitely, I'm talking about the base as the base part. So already we know that the pH is defined as the negative of the logarithm to base 10 of the hydrogen ion concentration. And so let me just when you wear spectacles, you look so cute. You look so cute. You look so cute. That's why I want Maureen to start wearing
Hey,
spectacles.
sir, please relax. So, sir, relax. The opposite logarithm down something. I didn't get it.
I'll give it to you. Don't worry. Just relax, baby girl. Just relax, okay? So yeah, we are talking about finding the pH and pOH of an aqueous solution. Of an aqueous solution. Now, I'm going to first consider the pH. When we say pH, we are saying that we define pH as the negative of the logarithm. The negative of the logarithm to base 10. The negative of the logarithm to base 10 of the hydrogen ion concentration. When it cuts, you join. That's why I'm not writing. I know you cut very soon. The pH is defined as the negative of the logarithm to base 10 of the hydrogen ion concentration. pH is defined as the negative of the logarithm to base 10 of the hydrogen ion concentration. So pH means the negative logarithm to base 10 of the hydrogen ion concentration. When the distance cuts and come back, I'm going to write a mathematical. I'm going to represent it mathematically, and so immediately cuts. Then you humbly join. Yeah, humbly join. So that is it. So pH will be equal to negative log 10 of H plus. pH will be equal to negative log 10 of H plus. Negative log 10 of H plus. That will be pH. And so these are things we are going to use in our subsequent calculations. Then when we are done, we are going to talk about, if you have time, we are going to talk about Ka and pKa.